All right, welcome. We'll let people show up. I'm going to do a quick introduction of who I am and what's going on. But you are in the, you know, Arduinos more than just teaching code, and so we're going to talk a little bit about Arduinos and stuff like that. But let me tell you a little bit about me. I think that STEM programs should be called STEAM programs because art without engineering is just dreaming, and engineering without art is just calculating. So Steam Clown is my alter ego. You'll see that in the slides a little bit. I'll talk a little bit about that. So who is Mr. Burnham? Hello. This is me in 180 seconds. I usually can only do it in about 4 minutes. We'll see how we do today because we're going to go really fast today. So I was born in LA. When I was 6 months old, my dad worked for an accounting firm, so we moved to Bogota, Colombia. Then when I was about 5, almost 6, we moved to Brussels, Belgium. Then moved to Cleveland, Ohio. And so when I was 12, got to see some cool learning eclipses. Got to meet John Glenn, and I cared about that because he was an astronaut, not because he was a senator. And then my dad changed jobs. He could go work for a bank in London. He could go work for a bank in San Francisco, or Bartlesville, Oklahoma. He chose Bartlesville, Oklahoma. So I spent my high school, junior and senior year there. But it wasn't so bad because school in Ohio was like not great for me, and in Oklahoma it was like awesome, right? But after school, high school life sped up. I went to Brigham Young University for a year, spent 2 years in Chile. Then I came back to Oklahoma State and went to Oklahoma State for 1 semester, which was important, right? It was important because I married my high school sweetheart. And then I went back to Brigham Young University and finished up an engineering degree there. So life as an engineer. I worked for a year for a little tiny company on the Utah-Nevada border. Was basically 6 employees at this telephone company, and mostly I built hardware there. I built design hardware that connected up to their hardware, and then wrote assembly code and some C++ code. Then I came out to California. Maybe my first real job was working at Amdahl. So I was, Carolyn's competitor because we were competing with IBM, and did that for about a year bit. And then I had a friend of mine working at a company called Xilinx, and I went over there one Saturday. He showed me everything, and I went, "This is my dream job. I have to have this job." And so 25 plus years later, that's where I pretty much spent my career. So life as a teacher, right? I always wanted to be a teacher, kind of noodled in my head. I actually did some summer coding camps. I was a TA in college. I did lots of training and stuff when I was working in industry, and so it kind of was a nice fit. My first year, 2016, I created and started a class in cybersecurity, and the school that I'm working at, Silicon Valley CTE, Career Technical Education School. They're like, "Yeah, we want to start the cybersecurity program," and I'm like, "Well, I know networking and stuff, but I'm not really a cybersecurity expert." They're like, "You'll be fine." And so that was a lot of fun setting that up. What was also really kind of interesting and sometimes super frustrating was working with the school and working with the district on trying to figure out like how we can actually teach cybersecurity when students actually have to hack networks and play on stuff when they're like on school networks. And so that was super exciting. And then we handed that off to another teacher, and I started a mechatronics program. So I teach mechatronics. That is mechanical engineering, electrical engineering. You mash those together, you get fire-breathing robots. And so my administration, they have like no idea. I have no idea what I do in my class. And as long as I'm kind of following my course outline, they're like happy. So fire-breathing robots. Let me tell you a little bit about my program so you kind of understand like where I'm coming from. So Silicon Valley CTE, if you're not familiar with it, it's a career technical education school. We work with 6 districts around us, 40 high schools, and we either bus students over in the morning or in the afternoon. But from the student's perspective, it's just a 3-hour class that they get to take in the morning and the afternoon, right? So it's just part of their high school curriculum. My class satisfies a physics requirement, so it's A to G physics, and so they can actually substitute their physics class, their junior and senior year, for my class. We learn AC/DC circuits, lots of breadboarding, things like that. Digital electronics, we program with microcontrollers. We're going to specifically talk about Arduinos today. We do some 3D modeling and 3D design, and we've got some 3D printers in the room. We do a little bit with pneumatics, and then just some programmable logic, industrial control, robotics, things like that. So what does that look like, right? So, we'll do lots of circuit diagram stuff, lots of breadboarding, lots of things with resistors and LEDs and transistors and all kinds of stuff. I program, right? Now, programming for me is actually a byproduct of what I actually want them to do. Because for me, it's more about connecting to the real world, sensors and seeing something happening, writing some code that actually interacts with that data that they're collecting, and then they do something. And so for me, I think Python's a better language, but I start out with C++ because that's what's on Arduino, right? And so we play with Arduinos, and then the second semester we learn Python, and we play around with Raspberry Pis and Jetson Nanos and AI stuff and all kinds of things. Like I said, we do some 3D printing. It's always fun when a student comes to me and says, "Hey, I got this robot, right? I got my robot, and I've got this sensor on the front. I want to connect this up. Should I use duct tape?" And I'm like, I wish there was a tool in this classroom that you could make a little thing to hold that, right? And they're like, "What?" And I go, "I wish," and I start pointing at the 3D printers. I'm like, "Oh," and then they'll go off and actually design something to hold their sensor, right? Because duct tape never works. I mean, it works, but it never really works. And then I do some stuff with some robotics, and we actually have a FANUC robot in the room that we can learn some industrial robot stuff. And then Halloween, we do Halloween, so I'm always big on Halloween. We actually do a big haunted house at the school, but I kind of wrap that into projects that students can do, which is Robot Club, right? So we don't have an after-school Robot Club program, but I just do it in class because I get the students for 3 hours every day, 3 hours. So we can just dig into stuff and leave stuff out and have a messy classroom, and they can do all kinds of stuff. And so I have my students always doing something at some project, right? They're building something for me, they're building some interactive system for me, and that project could be a couple of weeks, or it could be something all semester. It could be a generational thing where they're building only part of something that's going to be passed from student team to student team. So my hope for my students, and I think I'm echoing what Carolyn's saying, is that we really want them to be exposed to technology, even if college is not the path that they're going on, even if they're not going to be an engineer. I want them to be exposed to a lot of good technology. And I want them to have some really good debug skills and lab skills and be able to use a digital multimeter and oscilloscope and, being able to get into any lab in any industry in the Valley here and be comfortable with understanding how to set up some test jig and do some testing and whatever, right? So if that's their path and they're not directly going to college, this is a super great class for them. But then, of course, if they are and they have their heart set on being an engineer, it's a super great class for them to be really exposed to technology. And again, fire-breathing robots. So how bad can that be? All right. So that was a quick, who am I and what's going on in my life. But now we're here for what you guys are here for, which is talking about how to get computer science and technology into spaces that may not normally have that kind of technology. So I'm a huge supporter of open source. So everything I produce, I pretty much, it's available, Creative Commons, whatever. I know that a lot of teachers are like, I've bled on this curriculum. This is my lesson plan that I spent, 20 hours on, and I didn't get paid for it. I'm kind of done with that, right? Because one, the district can't pay you for the amount of time that you spend on all the stuff that you do, right? They go, well, you have a prep hour. It's like, seriously, right? And the other is, who are my competitors, right? I mean, technically, if you're in some of the districts that send students to our school, maybe there will be a few students who don't show up, but like, you're not having competitors either. So I'm all about trying to help people. So you should think about that and get on that bandwagon too. All right, why listen to me? 25 plus years in industry as an engineer. 7 years as an engineering teacher. I was Santa Clara Teacher of the Year. Then just this last year, I was STEM Teacher of the Year, thanks to the Tech Interactive nominating me. And I actually have been developing curriculum for Silicon Valley Education Foundation the last couple summers and some of their Python programs that they've been doing. I love what I do, right? This is just, I love this stuff. Okay, so who's here? What do you guys do? Real quick, just shout out a couple. Like, are you already doing technology? Who's used an Arduino before? All right, or other boards or other technology in their classrooms, like microbits and other things like that. All right, who's teaching high school? How about junior high, middle school? All right, cool. Just real quick, what do you teach? So science? Okay. Just math in general. Physics teachers? Anything? All right, cool. So what are your goals? Real quick, if a couple people could shout out your goals for today. What did you come here to learn?
My goal is to see you, how you are doing all this Arduino, and get inspired and take it back to my class.
That'll happen today. What else? Who else? Any other specific goals you want me to kind of focus on?
I do not know much about Arduino, but my friend who's know a lot of Arduino usually share with me what's going on, what they do. But I'm very basic, so I really like to know more and what I could do with. I don't know. I'm an upper elementary, like 4th, 5th, 6th grade student.
Perfect.
That I can use.
All right. Anybody else want to jump in? All right. So just got to keep track of time. Yeah. So let's kind of dive into that. We're probably not going to have much time to like actually do anything because that's a workshop. That's 3 hours, right? But I'm definitely going to show you what I do and all the resources that I have access to and utilize and kind of help you get inspired with some of the show and tell stuff that I have here and how you can, get Arduinos or really anything into your classroom and use it as a way to get kids inspired about computer science where you might not have come across as a thing that you do in your classroom. All right. If you have any questions, please just like raise your hand and I'll try and answer them right. Don't hold back. I know that sometimes, people say, wait till the end. It's like, then you're like, I want to ask a question. So just ask your questions as we go along. All right. Might have helped if you heard about Arduino, but no, you're just like most of my students. My students show up to my classroom and more than half of them have never done any coding. They've done no electronics. They've done nothing with robotics. They've never seen a 3D printer, right? And so don't feel like, I needed to know a bunch of stuff because you didn't. The goal here for me is to help you understand how you can integrate, this kind of technology into any kind of class that you're doing. I'm going to show you how I do it and give you some examples how you can do it too. And I'll try and provide you with resources of where you can do this, and we'll have some Q&A. So let's talk a little bit about Arduino. Wait, I thought there was another slide here. All right. So there was a slide that said, am I going to get a copy of this presentation? And the answer is yes. And I'll have a QR code, and you can get it. And of course, it'll be recorded, and so I'll have that available and send that out to you guys as well. All right. So did you say Arduino? All right. So we're going to talk a little bit about Arduinos, and and how you can take an Arduino and utilize that, in your classroom. Dropped an LED. There we go. So for me, like I said, Arduinos are only the coding part of this is only just because I want to be able to have something that they can interact with that helps them interact with the world, right? So my goal is that we're going to teach them about sensors, and they're going to be able to sense something happening. They're going to happen to have some code that they're going to write that's going to interact with that, and then they're going to interact with some motor or switch or solenoid or something, right? So that they can see that whole process. And the coding part is just a little piece of that, but that's the cool thing about it, right? And so an Arduino, it's just a little microcontroller, right? Comes in a lot of different flavors, and it lets you sense the world, interact with the world, and you can write code and tell it what to do when something happens in the world. It's super simple piece of hardware. It's a microcontroller as opposed to a microprocessor, and a microcontroller basically has everything inside of this chip, this little Atmel chip. It's got its own little memory and everything inside of there, so that it and interface controllers and I/O controllers, everything's like all inside of there. You have a bunch of I/O input output that are digital pins, and then you've got some input output pins that are analog, and so you can read analog signals or digital signals, or write digital signals out. And in general, the way you'll probably be using this, you'll just have it plugged into a computer, right? But then later, once you've got a program in there, you can plug it in, anywhere. I can plug this in, to a battery and have it run and do something interesting. I have no idea what's programmed into this right now. It comes in lots of different flavors. And so, most of the time you'll see ones like this or ones like this, the Arduino Uno, the Arduino Nano, but it comes in a lot of different flavors. And so if you're doing a big project with lots of I/O, you might want to go with the Mega, which has maybe about 40 I/O instead of the 13 and plus a couple analog ones. But it also comes in this one called the Lily Pad, which these are like little clips where you can like slide a little wire in or clip a little alligator clip onto it. And I've seen these used lots of times in like fashion design, and where you have conductive thread and you like slide the thread in, and then that goes off to something in the garment that's lighting LEDs and stuff like that, right? So lots and lots and lots of little options. How many Arduinos do you need, right? So I really suggest that you have, it's never too many, it's enough. You might think, because my class is a little unique because I only have 2 classes, and I got a big classroom, and I've used every single inch of my wall space as storage space. And so, I sympathize with the fact that you might have 3, 4, 5 classes, right? You might have, 200 students. And you can get away with having, a class set that everybody uses. But my recommendation is that you actually get a one-to-one with your students. And the reason why is because they're going to start building projects, and they're going to need to like leave them connected over time, right? So what I typically do, and I mean, this is like a classroom set. There's like 25 or so in here, right? You could have, classroom set could fit like in this space, right? But ideally, what you want to do is do something like this, where every student gets a bin, right? Now you think, okay, that's 200 bins, right? Well, you may or may not be able to do something like that, but you want to consider it. Now, you don't maybe need to go this big. You could probably go this big, right? And depending on how you set this up. What I've done in my classroom typically is I have a little board like this that I put together. And you can buy stuff like this, the little plates that this stuff goes on, where they get a breadboard, an Arduino, and some other stuff on there. And, that fits nicely into, Salvador's box, right? and they can keep their stuff put together, right? So that's kind of what I do. But like I said, you can go with something much smaller, like this, where you even go with a Arduino Nano and a cable and a breadboard, smaller breadboard. And so, a student's projects could fit in a container like this, right? That's probably more manageable.
Would you say that's the basic setup? Is the Arduino, the breadboard, and a power supply? Is that what you had on the original wooden block plate there?
Yeah, I mean, what's on here actually, there's a little motor controller, but yeah, you can plug in a power supply into here, or you just plug into your computer. It powers stuff on the breadboard, or you come in with the motor controller and do some stuff with motors and things like that, right? But yeah.
Because it seems like you're always going to be going towards the breadboard from the Arduino at some point. So
Yeah.
You might as well. I like how you have it mounted though, because in the classroom, organization is key. Yeah.
Exactly. So anyway, that's my recommendation,
Can you
right?
say that one more time? What were the 3 pieces on the board?
So on this board, and basically what you probably need. Okay, so if we're looking at this, right? This is an Arduino, a breadboard. You're going to have a bunch of little jumper wires, and then the stuff you're going to use, a little sensor. This is like a little light sensor, right? So I can tell how much light's being shined on something, right? So yeah, connect with me later too on exactly what you actually need, right? But yeah, it's an Arduino, it's a cable, it's a breadboard, it's some little wires, it's a bunch of little sensors, and it all fit into something like this. All right. So like I said, right, I do this. If you have the space to do it, this is probably the best option because it gives them a little bit of space. You'll see later because I have them collect some loot. But that's what I do. So what do I do in my class when I focus on Arduinos? So printers. One of my first projects that I do in my classroom is here's a screwdriver, there's a printer, find a teammate, go pull that thing apart, right? There are tons of things you can find inside a printer, right? So this is just the printer head, right? Little motor, printer head, and you get switches, you get little limit switches, you get little optical switches. This is just like another little switch. You got wires. There's all kinds of just crazy stuff, and plus motors. There's at least 2 or 3 DC motors, and there's a couple stepper motors inside of a printer, right? The kids love taking them apart, but then you can build stuff like this. All right, where's my plug? And so this is a project that I had a student put together, which is just a print head. And I've got some limit switches at the ends here, so I can tell when I'm at the end. And I got a motor controller driving the motor. And I got a little Arduino here that's connected up. And so as soon as I click one of these things, then it'll run. And I'm going back and forth, right? Now, the thing that we're going to connect up later is on this end, we can actually tell there is some sensors on the top, which I can tell if there's some object on this plate, right? And my goal is to actually have this fight with a robot where the robot goes, oh, I'm being told that there's an object here. Let me grab it. Picks it up. The thing goes, oh, there's no object. So it goes over here, and then the robot goes, oh, I need to put my object down. And then just have it go back and forth, back and forth, back and forth. But this, I mean, other than the time that we put into this was free. All of this was free except for the Arduino and the motor controller, right? And and filament for the 3D printers. But it wasn't a huge expense in the system. All right, can't lose my clicker. And so, and in this presentation, there's a link, right? There's a link to a whole presentation on Rube Goldberg project and how you do this stuff with the printer. Of course, now where did I go? All right. So, Arduino software. So, what do you do? What do you do with Arduino software? Well, two things. One is there's a site called Tinkercad, and again, there's a link here that you can go off to the Tinkercad. A little presentation on how to get a Tinkercad account set up. And Tinkercad is basically just an online tool. In fact, there we go there. Okay, so Tinkercad, but let's just go to Tinkercad real quick. And so it basically has designs. You can do stuff in 3D printing, but you can also do stuff in circuits, right? And so you can come in and edit some design. We'll go here because we might go here later. And so you can actually do all of this breadboarding with an Arduino, and not actually use hardware, right? So students can actually do this at home. They can create an account. They can do this at home. They can build something in Tinkercad, and then they can come in the real world and build the same thing if you've got the materials for it. But you can do a lot of this coding just on Tinkercad. And so I've got a whole little lesson on Tinkercad and stuff like that. And I'm happy to support anybody who's trying to figure this stuff out. All right. Oh, we've got only 15 minutes left. All right. The other place is you just go to the Arduino site, the Arduino .cc site, and they've got software. So you can download software. It's all free. It works on Macs, Linux, Windows. It also works on Chromebooks, but you have to do a little trick, and I think you might have to buy a subscription for that. But otherwise, for all the other tools, it's free, and I do everything on Windows or Linux. And so, again, that's all available. So I do a whole section on this. I have a site which you can link to, which basically has all my curriculum. Mostly, I'm kind of reorganizing this section as we speak, but I'm always adding more lessons, right? And I've got ADD, so I'm always switching from task to task, as you can see. But if you click on this link, then you're going to land on my Google site, and I've got a whole section here where I've got a whole bunch of lessons. So introduction. I've got a thing with Cisco networks, thing on Tinkercad. Then it's pseudocode, and then doing your first LED push button, variables, a foil switch, just all the different things, and then using a potentiometer, using a light emitting or a photoresistor, distance sensors, displays, right? All kinds of stuff that you can do. So, for example, there's one here on doing tones. So if you're in a music class, right, you could do tones. Right? You could take this, plug it in right here, and before you know it, right, this speaker came out of my printers, so it was free. And so you can have students learn it in physics. They can do a lot of stuff with frequency and tones and all kinds of stuff. In music, you could do. They could actually write their own music. They could create their own little, piano, right? They could do all kinds of stuff with something like this.
What's the URL for this site?
So I will give you my business card sticker, and there. But Steam Clown. Look for Steam Clown, and you'll find me. All right. go back to the presentation. All right, another thing I do is I basically do a kinetic Rube Goldberg project, right? Where the students take their Arduino. We've learned a bunch of stuff about sensors. So then they pick a sensor. They have their Arduino they got to write some code for. Then they have learned about motors and servos and solenoids and things like that. And so now in teams of two, they actually go build, some crazy thing. And I actually have up on California Educated Together, there's a whole module there. They say it's 4 lessons. It's probably like 8 or 9 crammed into that thing. And so you can go there and find that, and that's a whole set. And that could probably be, a week or 2 of material that you did in your classroom. I know that most of you like 50 minutes. What's your classroom time, right? Or sometimes you got block schedules a little longer, right? So I sympathize with you. But this is available that walks through just a whole crazy thing on how they can build some things. And that's just duct tape and swinging balls and dominoes. But in between is a sensor that senses something happening, some code that determines what to do when that happens, and then, doing something. And then that something that they do, the next team sees. And so I have this big cascading Rube Goldberg machine that happens with all these Arduinos doing something, seeing everything. And it usually starts out with I have a little robot skeleton Halloween thing that moves and starts something, and then at the end I have a little clapping monkey, right? And if it's successful, we get the clapping monkey. All right. So I won't go into it, but there's some links here. You can go see some Rube Goldberg projects on my YouTube, and there's just Google Kinetic machines. And then Robot Club, I always do a bunch of stuff for Robot Club. Well, where do we get our Robot Club ideas? If you haven't used Instructables is a great place to find projects. They're really well written tutorials that walk you through how to do something. A lot of times they give you too much information, in my opinion, for you to say, hey, go learn this thing, right? It's more about once you've got them learning about something, then you say, hey, go do this project. And then they can walk through and put something together. But usually it provides the code and everything. So really it's a step-by-step to get something working. And I feel like, that you need to augment this with a lot more learning where they have to struggle with stuff before they do stuff like this. The other place is Udemy. I got a link here to a little presentation on Udemy, and it's basically little classes. It's a site that they want to sell you $15 classes, and I tell my students, don't ever buy the classes. You can usually find the material somewhere else, but they have a lot of free classes. And so there's a couple Arduino classes on there that are free, and it's kind of tricky, but you got the link directly to the free class, so it's easy to find it. Sometimes they do this A/B testing at the site where you sign up and you can't actually get the free filter, but then other students are like, oh no, it's right here. It's like, what? I don't know what they're doing on their site, right? They're trying to figure out like how to sell more classes. But if you got the link to the free class, you can just your students can all join that class. All right, and then I do Robot Club. All right, so how to integrate them into your class? Because we've got 50 minutes. Yes.
Just real quick, when you set up your teams, I noticed you said 1 to 3. What's the optimal size of a team?
So yeah, that's a good question, right? I mean, teams of 5, they're disasters, right? 4 sometimes are still disasters. So especially this kind of stuff, when I do my Rube Goldberg, it's teams of 2. When I do anything that like, hey, I want students to help support each other, it's always teams of 2. If it's going to be a little bit bigger, I'll go with teams of 3, right? And sometimes we'll go with teams of 4. But 2 and 3, that's kind of my go-to, because otherwise someone's not working. Yeah. If somebody's absent, then you're So 3 is good. I've got that situation right now where I got a couple students out and I got a team that's like, you guys got to do the report. Well, no, my teammates haven't been here all week. It's like, you guys still got to do the report. All right, so how do we do this in your classes? So math class, right? you can do a whole ton of things where you can teach concepts and have them actually write code to figure that out. And so, for example, I don't have it out here. We'll just look at it online. So, for example, the fundamentals of most electronic circuits is a voltage divider, where you're trying to get a particular voltage at a particular place, and you're creating resistors above and below that point to basically create the actual value. And it's just a ratio. It's just a ratio of those resistor values creating that value. And so if I went off back to my Tinkercad design and zoomed into this design here, basically what I'm doing here is there's a component called a potentiometer, right, which is just a variable resistor. And I can take that and I can change the resistance of something, right? And I can sense that on my analog pin on the Arduino. And so I can write some code, and it takes a value from 0 to 5 volts, and it splits it somewhere in there, so you get 1.6 volts, right? Well, 1.6 volts is about a third of that 0 to 5 volts, and that gets translated into a number that's between 0 and 1023, right? Because it's an 8-bit number, it's 8-bit number or something like that. And I can't remember how many bits, but you translate that. So now each bit is 0.005 volts, right? And so what this is doing is it's basically a digital what? There can't be error in my code. Oh, it's because I'm not connected to a Arduino. I want to connect to which Arduino? Oh, you know what? We'll connect to this Arduino. All right. Oh, yeah. Actually, it doesn't matter. Okay, so, all right. All right, we won't do that. What we will do is we could look at. All right, we'll do this in a second. Let me finish up talking about stuff, and then we can see how quickly we get kicked out of here. But so you can do all kinds of things. You can talk about ratios and fractions and things. You can do stuff with prime numbers. There's a super great one. This one's great. I spend way too much time on TikTok.
A few weeks ago, I went to an exploratorium, and one of the demonstrations that they had there was this really neat game involving random numbers. And honestly, the game kind of felt like magic at first until I started thinking about it and realizing what was going on. So I'm going to share a version of this game here. So here's what we're going to do. I'm at random.org, and I'm going to use this website to generate 50 random by 7.
All right. So the goal here is that you actually have a bunch of random numbers get generated, and then you figure out, like, if you take that random number and then you go that random number. So you pick 4, then you go 1, 2, 3, 4, and then you pick 1, then you go 4, and then you go 4, then you go 1, 2, 3, 4, and you kind of go through this whole thing, right? And it turns out that it doesn't really matter what most of these numbers are, because you're going to get stuck on this number 4 right here, like always. There's going to be a number that you're going to get to, And even though you've generated random numbers, you're always going. There's going to be a place where you get to the point where you can't go forward anymore, and it's always that same number, right? Well, I thought, oh, that's a great coding exercise. I'm going to have my students do this. They're going to learn about random numbers. They're going to learn about how we suck at generating random numbers. They're going to learn about lists and being able to go through lists. They're going to learn about being able to keep track of where you're at and counting forward and setting up loops and all kinds of super great, right? And so you can do all that kind of stuff and like do it on Arduino, like have an LED turn on at the end, things like that. All right, physics, right? There's all kinds of sensors, weather sensors, flex sensors, sensing force, accelerometers that you can tell if you're what position you're in, all kinds of stuff, right? And it's a super great place to like have them code it, collect their data, and do something. But they're actually touching hardware and not writing code in a physics class. Music, like I said, right? You can do lots of stuff with speakers and tones and things like that. Life science, right? Set a weather station up. Set a let's grow plants under different light conditions and control it and turn it on and off and sense how how wet the soil is. All those kinds of things can all be done with an Arduino. All right, you're Arduino experts. Excellent, good job. Give yourselves a hand. We don't really have time for a lab, but I do have this. I will make sure that this presentation gets sent out, as well as if the recording comes in pretty good, we'll send that out as well. But that'll land you there. You can connect with me on LinkedIn. You can email me. You can see my class. And so please connect with me, right? Like I said, none of you are my competitors. I'm happy to share all of my lesson material, the hundreds of hours I led. I will share that with you. So please connect with me. If you've got questions about setting something up in your classroom, please use me as a resource. All right. So with that, I did want to try this out because this obviously is awesome. So let me see if I can get this up and running. What this is basically a pressure sensor. Let me bring up my Arduino. Nope, not that one. Pressure. Okay, port number, I don't know. Port number 6, I think. Maybe port number 4. All right, victory. All right, so what I've got here, oh, no. Yep, okay. Okay, so what I've got here is that we're basically reading a value that's coming off of this little sensor right here. And since it's kind of neutral, it's about in the middle, right? 511 would be like the middle of the 0 to 1023, right? And so if this works, right, I should be able to see, look at that. All right, I can change the pressure to almost maximum just by squeezing this balloon right here, right? And I think this will make it go the other way. Yeah. Right. So think of the physics things you could do with this, right? And loads on these things. I mean, it's just crazy, all kinds of stuff. There are hundreds of sensors, and they're all cheap. You can buy a pack of it's 37 sensors, although at least 7 of them aren't sensors, they're actually outputs. But like, temperature sensors and infrared sensors and light sensors and all kinds of stuff. And that kit costs, I don't know, $20.
Could you use this to like solve for 9.8 or something like?
You could, yeah, absolutely. So there are sensors that actually have accelerometers and stuff in them. And so you could actually have it with a little light wire. You could actually have it on something and drop objects and actually do measurements of acceleration and 9.8.
Could you also use this setup to get a graph and calculate the weights of things, like based on the number that you popped up there?
Yeah. So let's see if I can stop this.
Yeah. Right. Just do one side. Yeah. Interesting.
Serial plotter. Let's see if this works. Right. So I'm plotting this. Right. So I mean, yeah. Now here's the other thing, and I know we've got to stop here. I'm 2 minutes over. But like I'm showing you how to do this to Arduinos. But there's a new device out from the Raspberry Pi Foundation, which is a Raspberry Pi Pico, I think it's called. But it's a Raspberry Pi 2040, and you want to buy the 2040W because that comes with Wi-Fi, and they're like $8, right? They're like $8 if you can find them. Well, I bought a bunch from DigiKey, and they had a set, and I jumped in, and I got them, bam. But like you can do all kinds of stuff. Like one of the projects I'm going to do in my classroom, I'm going to have the students actually do a bunch of design. There's going to be some 3D stuff. We're going to do the construction class has a laser cutter, and so we're going to actually cut some stuff out. But like I'm going to do a thing where I take, it's probably going to be the Raspberry Pi, but like I could do this with an Arduino, right? This thing, beautiful, right? What am I doing? Well, I'm going to have one of these for every student in the classroom, one set for all my stations. And I'm going to be able to do things like, all right, let's start this project. Everybody make your like screen. Okay, so if anybody has a problem or need help, right? Don't just stand there with your hand up. Keep working, but like set your light to red, and then I can just like walk around and fix all the red lights, right? But my students are going to build these for me, right, as part of the class, and stuff like that. So, all right, like I said, thank you very much.